Hello student, this is Suman Sharma from SVM Sinidih and this is the first video for class 10. Now we are going to start this chapter. Students, let's imagine very beautiful scene of a lightning city at a night. As I said this, you all will have understand that our topic is electricity. Electricity is very much important for all of us. In our day-to-day life, we use a lot of things and in most of that we use electricity. If we switched on bulb, then we use electricity. If we use computer, our mobile phone, then we use electricity. Electricity is used in our home, in industry, and for operating the bulbs, operating fans, and for any heating purposes. In our home, there are so many appliances which runs with the help of electricity, like our television, refrigerator, mixer grinder, cooler, etc. In industry, it is used to run various type of machine and transport sector. Electricity is used to pull electric trains also. So students, without electricity, we cannot imagine our life. To understand electricity, let us have some common experiments. In the first experiment, which is known to all, that when we rub the comb in dry hair, then this comb attracts the small pieces of paper, as you can see in the image. That first there is a comb, and in this figure the comb does not attract the small pieces of paper. But when we rub the comb against the dry hair, then the comb is electrically charged and it attracts the small pieces of paper. In the second experiment, when we try to stick the balloon against the wall, then it cannot stick to the wall. But when we rub it against our hair, then the balloon is electrically charged. And after this, if we bring this balloon near the wall, then it sticks to the wall, as you can see here. Here again the balloon is electrically charged. That's why it is stick to the wall. Now, in describing these two experiments, the word charge comes. So firstly, we will define or we will understand about charge. This electric charge can be understood by using its property. Here, the definition of electric charge is given. So the simple or quiet definition is that charge is the inherent property of a matter that feels force of attraction or repulsion due to excessive or deficiency of electron. Students, you know that if we placed two protons, suppose I am trying to explain it. If we have two protons, first is placed here and second is placed here. If we place two protons near one another, then they repel each other, like this. Means the force of repulsion arises here. If we interact two electrons in the similar manner, if we interact two electrons, then again both repel each other. That is again the repulsive force. But if we interact a proton and an electron, then they attract each other. They attract each other. So it means that the electron or proton must have some property. Because of that, the repulsive force or attractive force arises or created. So the fundamental particles, that is the electron or the proton, must have some property due to which the electrostatic forces arises, and that property is called charge. So charge is defined by using its properties or its behavior. And in the second point, there are two types of charge. First is the positive charge and second is the negative charge. Positive charge simply due to the deficiency of electron, and negative charge is simply due to the excess of electron. The SI unit of charge is coulomb and it is denoted by capital letter C. And the last point is that it is detected, or charge is detected and measured using a device which is called electroscope. In the next slide, we will study about the properties of charge. Now, the first property is that the total charge of the universe is conserved, that is constant. So student, charge is a conserved quantity. This simply tells us that charge can neither be created nor be destroyed. It can only be transferred from one body to another body. So we can say that the net charge of the system will be zero as electron and proton are of the same magnitude and opposite sign. The next point is that like charges repel each other and unlike charges attract each other. You all know it very well. The next point is that charges are additive in nature. This simply tells us that they behave like scalars and we add them directly. To understand it, let us consider a system. Suppose that we have a system like this. And the system consists of two charges Q1 and Q2. So we have to find the total charge of the system. Then the total charge of the system is equal to Q1 plus Q2. We will add them directly. If Q1 has the magnitude of plus 1 coulomb and Q2 has the magnitude of minus 2 coulomb, then we have to find the total charge of the system, that is Q is equal to plus 1 coulomb plus minus 2 coulomb. That is plus 1 coulomb minus 2 coulomb is equal to minus 1 coulomb. So we can say that the charges adds up directly. Now the third point here is that charges are always quantized, or we can say that quantization of charge. The principle of quantization is used to calculate the total amount of charge present in the body. Here the formula is written. This property tells us that the charge is an integral multiple. The charge is an integral multiple. Here n is the integer. Charge is an integral multiple of the basic unit of charge. Here E represents the basic unit of charge. And the value of basic unit of charge is 1.6 into 10 to the power minus 19 coulomb. That is the basic charge of electron. And n is the integer. And it can be either positive or negative. But it cannot be a fraction. So, by using this formula, we can calculate the total amount of charge present in it. Student, the very important point here is that a single coulomb of charge contains nearly about 6.25 into 10 to the power 18 electrons. 10 to the power 18 electrons. Particles do not have high magnitude of charges, and we will use microcoulomb or millicoulomb. So there is a conversion that 1 microcoulomb is equal to 10 to the power minus 6 coulomb, or 1 millicoulomb is equal to 10 to the power minus 3 coulomb. These are the two conversions, you have to remember it. Okay. Now, in the next slide, there is a map. In the map, you have to memorize it so that you can make the statement or you can learn the formula to use in the numerical. So there is an electric charge, and electric charge, what is it? It is a fundamental property of a matter. When the charge is at rest, then it produces electric field itself, and when the charge is at motion, then it produces magnetic field also. The SI unit of charge is coulomb, and the smallest possible charge, that is electron, and its magnitude is minus 1.6 into 10 to the power minus 19 coulomb. Charge can be positive and negative. Positive means simply losses of electrons, and negative means simply gaining of electron. Now, charge is a scalar quantity. It is additive in nature, and it is always a conserved quantity, that is constant. Now, charge, electric charge are quantization in nature. It means it is a quantized quantity. That means charge on a body is integral multiple of charge on electrons. Students, in the next slide, we will study about conductors and insulators. These 2 points are very simple, that you all know it. Conductors are simply that substance through which the electric charges can flow easily. There are so many examples of conductors, and insulators are those substances through which the electric charges cannot flow easily. And the example of insulators are also present here. You can also put some more and more examples of conductors and insulators. In the next slide, there is again a map. In the map, here is the conductor and the insulator. And these are the two types of the category of material. In the conductors are substances through which electric charges can flow easily. Some examples are all metals like copper, aluminium are examples of conductors. And in conductor, the presence of electron makes any material a conductor. That means where does excess electron come from? And that excess electron come from in a conductor that the free electron are held loosely by the nuclei of the atom so that the electrons can move. In the insulator, substance through which electric charges cannot flow. And the examples are glass, rubber, mica, plastic, drywood, etc. And in the insulator, there is an absence of free electrons in a material. Why? Because in the insulator, the electrons are strongly held by the nuclei to their atom, so that we can define or classify it as conductor or insulator. Now, in the next slide, there is a numerical, and this numerical is very important. As we know that here the question is given, calculate the number of electrons we have to find, and as you have seen in the quantization of charges, and is the number of electrons. Okay, consisting 1 coulomb of charges, then Q is equal to 1 coulomb of charge. Charge on 1 electron is already given. Then we have to find the number of electrons, and it is given that 1.6 into 10 to the power minus 19 coulomb. So you have to use the formula that Q is equal to NE. Here E is given and total charge is also given. So you can simply put all the given quantity in this formula and you can calculate N. That comes 6.25 into 10 to the power 18. Means in 1 coulomb of charge, 6.25 into 10 to the power 18 electrons are present there. As you solved in question number 1, in the same manner you have to solve this question number 1. The difference is that as I have written here 1 coulomb of charge, then you have to written here 2 coulomb of charge, and the all procedure are same. In the next question, what are the conductors and insulators? You can simply differentiate between conductors and insulators and can put a lot of examples of it. And the unit of charges is, that is coulomb. Very simple. Now student, in the next slide There are some multiple choice questions. All three charges are integral multiple of a unit of charge, where E is, what is the value of E? That is 1.6 into 10 to the power minus 19 coulomb. Simple. SI unit of charge is coulomb. And which is the good conductor? Then copper is the good conductor, and the last, the number of electrons constituting 1 coulomb of charge. In the solved example of 1, this question and that question is common, means same. So you have to try this and solve all these questions by yourself. Thank you.